So for our first homework here, question number 1, which of the following is the probably rounded average given this data here, right? So this is the data sequence we have, right? 6 numbers, right? 6 numbers. Now, which answer will be the right answer, everybody? In fact, I mean, for this question here, I don't even need to do the calculate average. Officially, how would you calculate average? Like you need to add all those numbers. You need to add all those numbers together divided by 6, right? And try to find out what's the answer, right? But it turns out actually we can be, I mean, usually I say, if we can be lazy, why not? Why? We don't even need to do the calculation here. We can simply look at the answer here, right? So one difference you see here is like how many decimal points we want to keep. Remember, what's the rule of thumb we just learned, right? When we calculate average, how many decimal points we need to keep, right? If the original data sequence, how many decimals they have? They have 0. Right? They have a 0 in the original data sequence. That means we always keep 1 more, right? That means what? We only keep 1 decimal points. That's the average, right? That should be the answer. I mean, I don't need to do the calculation. 7 plus.
What if that decimal point was a 0? You might just leave it out.
I mean, the answer should keep 1 decimal points. So all the answer here, you only have 1 answer with 1 decimal points. That's my point, okay? So you got 0, you got 2 decimals, you got 0, none of them reasonable. Is that clear? That answer your questions? So we don't really need to add these together to divide by 6. No, yeah. So if you do this, I mean, someone was asking, right? Say if you add them together, divided by 6, what if it's happened to be like lines 0.0, right? You need to keep that 0. You shouldn't get like line here. So there's no way for this answer to be a reasonable answer, okay? So we simply look at what is the, how many decimal points we have here. So our only answer here is the B, 9.7. All right. Find the average of this data set. Okay, then you do have to do the calculation here, right? We cannot, second one here, add them together, divided by 5. I'm not going to cover that. Number 3, let's see, let me erase those ones here. Number 3, find out the average. Okay, so add them together, divided by 6, right? Now, I would say the answer should be either C or D, right? Because there's only 1 decimal point here, right? And most likely, the answer should be D, right? Because a 4.9 is too small. I mean, how come you have the average less than all the numbers? No way. So this one should be crossed out. So the answer should be D. I mean, you don't have to add them together, divided by 6. Nope, you don't need to do that. The answer should be D. Is that clear, everybody? So, I mean, looking at this data sequence, 0 decimals you see. That means in the answer, we're expecting 1 decimal point. So the answer should be either C or D, right? Cross out A, B. Now, is that C or D? Which one will be reasonable? We simply check all the numbers here. They are bigger than 5, right? How come you get an average of 4.9, right? So this one cross out. The answer, the only possible answer should be D, right? All right. So that's for this question here. Let me erase that. Number 5, what is the mode of this data set? Okay, that's pretty straightforward, right? You want to put this data sequence in order and find out which value happening the most frequent, right? Number 5, a student has an average of 78. Okay, on 7 chapter test, okay? So on 7 exams, right? Average of 78. Okay, if the student score on 6 of the tests so they give you the 6 of them, right? What is the score for the other one, everybody? So you mean this case here, if you have to do that, you add up this together, right? And then plus, say this is our x here, the number 7 exam, right? And then altogether you divide by 7, it should be equal to what? It should be equal to average 78. And try to solve that equation, right? Try to solve that equation. Is that clear? So you add those together, and then plus x. That's the one we are trying to find out, right? And then divided by 7. The answer on the other side is equal to 78. That's the average. And try to solve for this x. Everybody, this is a high school algebra. Okay. Now, I'm going to blame your algebra teacher. Okay. If you cannot do that. Now, number 6. A data has a median of 84. 6 numbers in the data set are less than the median. The data set contains a total of n numbers. So let's try to understand this question, right? Median, that means what? The sum, like the middle point, right? That's the one we studied. They also mentioned that there are 6 numbers less than the median. Say here is the median, for example, right? And we know that is what? 84, right? That's right in the middle. There are 6 numbers on this side, less than 84, 6 of them, right? And then tell me how many number on this side, or should be also 6, right? Tell me how many number total, 13, okay? That's, I'm going to skip that, okay? That's too easy. Number 7, a data set contains 3 unique values. Which of the following must be true? Okay, so this is a little bit 3 unique value, right? So somebody say, how about I use like 2, 3, and 4, like for example, okay? Then you will find out, looks like that. All of them, they are true, looks like, if you do that example, okay? And then how about like line 10, 11, like that, 3 numbers, okay, line 10, 11. You may realize, okay, all 3 A, B, A, C, D are also true, right? I mean, those are for the spatial case, right? I change that 2, 3, and line like that, okay? Like this case here. Then A is not right, C is not right, D is not right, none of those, okay? So they are asking like this in general, right? If you have a data set with 3 unique values, right? Which one? I mean, they put this like must be true. That means what? Like always true. You can understand that one. This one is not always. Sometimes, right? Like 2, 3, 4. Sometimes it's right? If it's for that data sequence, right? This one sometimes only. This one sometimes only, right? Because that's the idea. All right, I'm going to erase that. Let's see. Number 8. Middle range, well, do the calculation, the highest plus the lowest divided by 2. Median, put them in order, find out, right? Put them in order, find out. Find out the sample variance. Everybody, the variance, remember we have the S formula, right? S squared, right? Is equal to, there are 2 formulas, you can do that, okay? I'm not going to cover that. So you can follow the example we have mentioned in class, do that step by step, or using the other formula, right? 2 formulas. It's your call. We are not going to do that here. Now, given the average of the data set is 25, standard deviation is 3. What's the coefficient of variation by the formula, everybody? By the formula, the CVAR, right? Coefficient of variation is equal to the standard deviation 3 divided by the average 25, right? Multiplied by 100. That's it. Is it right? Yeah. So that is the, let me see, 12%. 12%. What's the, yeah, multiplied by 100%. The answer should be in a percentage format. Okay. Now, number 13. Completion times of a certain race was 3 hours, standard deviation 0.5. What can you determine about this data by using Chebyshev theorem, right, with k equal to 2? Everybody, think about that. K equal to 2, that reminds you, should be 75%, is right? Should be 75%, okay? Yeah, so that means, I mean, there's no way for the A, B to be true, right? Okay. Now, the average is about 3 hours, right? Let's write down 3 here, and then 2 standard deviation, right? So 1 standard deviation is half an hour, right? So 2 standard deviation is like you have half an hour here, you have another half an hour here. So what's that one? Should be like 4, right? So 3.5 and 4. You minus half, you minus another half. So you got this one here, it should be 2. So this one should be 75% plus. That's the Chebyshev theorem to tell you, right? Like say you have all different kind of data points, right? So that's the range between 2 to 4. And we say at least 75% of those times between 2 to 4. That's the answer, right? That's the answer. That's easy, and it's very straightforward. I think I should jump to the number 19 later using the Chebyshev. That's a tricky one, okay. Number 14, using the Z formula, okay, the Z-score, standard score formula. I'm not going to cover that. Number 15, using the standard deviation formula. Everybody, be careful. I got an email from someone that, Professor, I cannot get the answer right, okay? So if you are trying to calculate using a formula, you are getting S squared using a formula, okay? So at the end, you got whatever you have here, right, equal to blah, 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 some number here, right? That's not what this question asking. They're asking standard deviation. So what's that mean? You need to take the square root of that number. They're asking S. They are not asking S squared. Is that clear? So make sure you remember after you do the calculation, take the square root. Otherwise, you cannot get the answer. Okay. Number 16, 2 students, right? One is in the art major, the other one is in the theater major. We're trying to see which one is better, right? The same example we mentioned in class. Everybody using the same formula. The Z-score, standard score, right? To calculate the calculation. I'm not going to calculate, explain that using almost the same example. We have a math person, we have a biology person, right? Number 17, average weight of adult male bison in particular. This pound with standard deviation this. Find the weight of adult bull whose Z-score is 1.5. Everybody? I mean, I don't quite get what I mean, like bison is some animal or something, but that doesn't matter, right? Which is okay, but I know the average they're talking about here is average, this one, right? Standard deviation, this one. Z-score is that. So in other words, the Z formula is what? Z is equal to X minus mu divided by standard deviation, right? So you plug all the information into this formula and you try to find out what is X. Okay, I'm not going to cover that. Number 18, a baseball player has the batting average 0.325. Standard deviation is also given. What is the Z-score when the bats is 0.417? So in other cases, we plug everything into this side here. Try to find out what is the Z. Okay, that's pretty straightforward. I'm not going to cover that. The tricky part is the number 19. Number 19, according to Chebyshev theorem, the maximum proportion of data values from a data set that are more than 1.5 standard deviation away from the mean. Everybody, this is the tricky part. If you remember the Chebyshev theorem, right? Say here's the average, right? Remember the K we mentioned, the case we are going to ask, right? Is equal to K equal to 3, K equal to 2, K equal to 2.5. Oh, there's one more case here, K equal to 1.5, right? So those are the cases. So if you do the calculation here, if you plug K equal to 1.5, everybody, into that formula, it's 1 minus 1 over K squared, right? That's going to be the probability of within like 1.5 standard deviation away. Say here's the average, you have 1.5 standard deviation above, right? You have 1.5 standard deviation below, like that. Here's the average, right? So you plus or minus 1.5 standard deviation, like that, right? So Chebyshev theorem to tell you what's the percentage in the middle should be, right? So when you plug 1 minus 1 over 1.5 square, everybody, you do the calculation. So you should get 1 minus 1 over 2.25. 2.25 is about, let me see, it's like 9 over 4. So it's 4 over 9, and 1 minus that, which is 5 over 9, right? 5 over 9. Yeah. So that's about the, that's about in the middle, everybody. That's what's the probability in the middle, okay? If you do that, let me see, it's 44%, is that right? No, 50 something, is that right? 50, 55 something, 55.5, right? If you do that, 55.5 or 55.6%, okay? Yeah, if you do the calculation here, you will get an answer 55.6%. I should be more smart, put the answer 55 point something here, so that some people will say, oh, that will be the answer, right? No, this is not. Why? Be careful. Chebyshev theorem tells you that it's within 1.5 standard deviation. In other words, like this range. But if you pay attention to this question here, they're asking more than. More than means what? It's outside, right? It's outside here. Because altogether is 100%, right? You minus this one in the middle is 55.6. So it means the outside should be what? 44%. The answer should be A. 1 minus 55.6, 44.4%. Is that clear? That's the keywords, more than. Number 20, let's see, bear with me. We are kind of over time today, okay. We should be finished pretty soon, okay. Now, let me see. So number 20, using the Chebyshev theorem, right? At least 75%, that means K is equal to 2, right? So you plug in the formula, easy. The range of a data set is the difference between the highest value and the lowest value. The range, I mean, we mentioned that in class, right? The range is the middle range. The middle range is the highest value plus the lowest value divided by 2. That's the middle range, right? The range is the difference. The range itself, yes, that's right, right? The highest value minus the lowest value. Yeah. Be careful for those terms here. Number 22, determine the range of these data sets. Okay, so it's the highest minus the lowest. That's easy. Not going to cover that. Number 20. The coefficient of variation is the mean divided by the standard deviation. The other way, everybody. The other way. This is a false, right? Chebyshev theorem used to find out the minimum percentage of value in a data set that will fall within the certain distance of the mean. That's true. Minimum, right? Remember, 75% is the minimum, right? Could it be more than that? The variance of a data set is the square root of the standard deviation. Everybody, is the other way, right? So the standard deviation is the square root of the variance. All right.